Hello everyone and welcome to a lesson of physics. So today we are starting off with the past paper practice of the topic projectile motion. So I've tried to compile all the kind of questions that they can ask you in the exam. So let's start off with the first one. A ball is thrown from a point P. So I'm not going to read the statement. You can see everything from the diagram as well. So the first part is calculate the horizontal component of the velocity u. So that's an easy one. We can easily find the components of the velocity if we are provided with the velocity and the angle. So the horizontal component I'm going to represent by ux, and that would equal to u times cos theta. So u is 12 times cos 50. Because theta, the angle in this case is 50. Then you can hit it on the calculator. 12 times cos 50. And what we get is 7.7 into SF. We can write it as 7.7. So this is the horizontal component of the velocity. Now we need to find the vertical component as well. So the vertical component would simply be, you can represent by uy, and that equals to u sine theta. So u was 12 times sine 50. Then you can once again hit it on the calculator. So 12 times sine 50. And what we get is 9.19 into SF. You can write it as 9.2. So let's move on to the next one. In this one they are asking, show that the maximum height reached by the ball is 4.3 meters. Maximum height reached by the ball. So whenever you get a question of projectile motion, the rule of thumb is you have to break it down into horizontal or vertical paths. Either you deal the cases horizontally or vertically, so depends on the situation. Now since you have to find the maximum height, that implies that you need to break it down for the vertical motion. You need to consider the vertical motion. Now everything that I'll be writing here would be representing the vertical motion. So for the vertical motion, the initial velocity was 9.2. So I'm not going to write y in the subscript to represent that is the vertical. I've written already at the top. That is the vertical motion. And the final velocity for the vertical motion would be 0, because that's the point where the ball reaches the maximum height. All right. And what you need to find is the distance covered. So maximum height would be basically the displacement, but the vertical one. So what you do is you can use the equations of motion, and here the most compatible one would be the third equation, which says v square equals to u square plus 2as. That is given on the question paper itself at the formula sheet. So we need to find the value of s, and if I rearrange it, it'll be v square minus u square divided by 2a, and then it can be written as minus 9.2 square divided by 2 into minus 9.81. If you're moving up against the gravity, if you're moving upward, then the value of g is taken as minus 9.81. If you're going downwards, then we consider the value of g as plus 9.81. And from here, you have to hit it on the calculator. Before that, you can cancel negative sign from the top with the one at the bottom. So what we have left with is 9.2 square of it, and then divided by 2 times 9.81, and then we convert into SD. And what we get is, in 2SF you can write this thing as 4.3. So 4.3 would be the answer from this one. Alright everyone, so let's check out the next part. We need to determine the magnitude of the displacement PQ. So if I come up to the diagram, the magnitude of displacement would be the shortest distance between P and Q. Alright, so we need to find this thing, but at the same time, you know, we do have the value for the horizontal distance and we do have the value for the vertical distance as well. So we have both the values, the horizontal distance and the vertical distance. And what was the horizontal distance? Well, the horizontal distance was, let me see, the maximum height reached by the ball was 4.3. okay, it was 4.3, and I think we don't have the value for the horizontal distance. Okay, so we can easily find the value for the horizontal distance first. So I'm going to write for the horizontal motion. So since I have given the title here that I'm representing the horizontal motion, now I'm not going to use the subscripts. So for the horizontal motion, the distance would be whatever the speed is. It remains constant for the horizontal motion times the value of t, like how much time it takes for the ball to reach to that point. That would be your value of horizontal displacement, all right, or horizontal distance, because we're traveling in the straight line if we consider the horizontal motion. Now the thing is, we do have the value for the horizontal velocity, which is 7.7, because that remains same everywhere, but we don't have the value for the time, like how long would it take for the ball to reach or to cover the horizontal distance. So one of the quantities that are same for the vertical components, for the vertical motion and for the horizontal motion, is the time. Since the ball covers vertical motion, completes the vertical motion and the horizontal motion at the same time, in the same amount of time, so time is something that links horizontal and vertical motion. Now we cannot calculate the value of time from the horizontal motion because we don't know the distance in the first place. And matter of fact, we have to find distance, and that's why we were supposed to find time. So we can find the value of time from the vertical motion. So I'm going to write here everything for the vertical motion. So for the vertical motion, if I consider the vertical motion, then I can say now for the vertical motion, time needs to be found out. The final velocity at the maximum point would be 0. The initial vertical velocity, I'm considering the vertical motion only, okay, was 9.2. The acceleration would be negative 9.81 meter per second square. I can easily find the value of t from here using the first equation of motion, which is v equals to u plus at, or the very definition of acceleration itself, a equals to v minus u divided by t, and from here t equals to v minus u divided by a. So v minus u divided by negative 9.81. You can cancel out negative signs on the top and on the bottom. So let's hit it on the calculator. 9.2 divided by 9.81, and the value of time that we get is 0.937. Okay, you can take it as 0.938. Okay, since this is not the final answer, so we can use the same value to more number of decimal places, so that our answer should be more accurate. Then the final answer can be rounded off to 2 or 3 SF depending on the data. So this is the time that the ball would take to complete the horizontal motion as well. Now we can find the horizontal displacement, and that would be whatever the horizontal velocity was, 7.7. So 7.7 into 0.938. Then I'm going to hit it on the calculator. This answer, we try to carry forward it, okay, instead of erasing it and writing down the rounded value. Try to just carry forward it. So what we get is, from here, what we get is 7.22 meters. 7.22 meters. So this is a horizontal distance, 7.22, and the vertical distance was 4.3. So this one is 7.22, the upper one, the vertical one is 4.3. We need to find the displacement. We can use the Pythagoras theorem. So that would equal to 7.22 square plus 4.3 square, and then the square root of it. Then you can hit it on the calculator. 7.22 square plus 4.3 square and equals. So what we get here is 8.4 meters. So for this one, in 2SF, the answer that you get is 8.4 meters. And the marks are cropped out here. By the way, this question was for 3 marks. So you get 1 mark for finding the time, you get 1 mark for finding the horizontal distance, and you get 1 mark for finding the final answer. Alright everyone, so let's move on to the next one. Here we have another question. Define velocity. Velocity is the rate of change of displacement. Acceleration is rate of change of velocity. So let's move on to the next part, part B. Everything is given on the diagram. This is the second case of projectile motion, which is half of the projectile motion. Air resistance is negligible, that is always given. So the first thing that we need to find is calculate for the ball the horizontal velocity as it leaves the table. When I write the caption here that I'm representing the horizontal motion, then I'm not going to write the subscripts. So for the horizontal motion, S equals to V into T. Distance equals to speed into time. So V equals to the horizontal velocity would be the horizontal distance divided by time. For time, we don't call it horizontal time or vertical time because it's the same for both of them. Now the question is, what is the horizontal distance? So the horizontal distance is 1.50. So we write 1.50 here. And what is the time? Are we provided with the value of time? If we were provided with the value of time, we could have found the horizontal velocity easily. We could have divided by whatever the value of time is given, let's say 0.5 second or 0.25 second. We could have divided the distance by time. But since in this question, time is not given, and that's precisely why this question is for 3 marks. So we'll have to find the value of t by some other method. And the easiest thing that should come in your mind is you'll be finding the time through the vertical motion. So for the vertical motion, if I write down the equation for the vertical motion, the initial vertical velocity is 0. You see, the ball of the mass 0.45 kilogram, that is launched horizontally. So for a vector that is horizontal, it has no vertical component. So initially the entire velocity is horizontal, so there is no initial vertical velocity. So initial vertical velocity is 0, and the vertical distance is 1.25. The acceleration, as the ball has to go downward, the acceleration would be 9.81. What if I use the second equation of motion, s equals to ut plus 1 over 2 at square, which is given on the formula sheet. So we can insert the values in that. Ut would be reduced to 0 because u was 0, so distance was 1.25. These two would be multiplied on the left side, a would be divided on the left side, and since you have t square, then you have to take square root of it, and that equals to the value of time. Now you need to hit it on the calculator. So you press the square root, then you enter the fraction, because we want to write this thing as it is. 1.25 times 2 divided by 9.81 equals to, let's see what we get here. And for this one, we would be getting, let me press the equals, 0.50. Alright, so the value of t, the value of time that you get from here is 0.504. You can write to 3-4 decimal places. Matter of fact, you should be carrying forward the answer, because this is not the final answer, so you don't need to round it off to 2SF or anything. Now we rewrite the formula. We have 1.50 divided by whatever the answer was previously. So we hit it on the calculator once again. So I'm going to press the fraction. 1.50 divided by whatever the answer was, and we get 2.97. Now you can round it off to two significant figures, and in two significant figures you'll be getting 3.0 meters per second. So this is the answer for this one. Let's move on to the next case. Now you need to find the velocity just as it hits the floor. That velocity needs to be found out as the ball hits the floor. So when they ask you to find the velocity, in which they have not specified if this is the horizontal or the vertical, it means you need to find the resultant velocity. And the resultant velocity is always related to the horizontal and vertical velocity by Pythagoras theorem. So let's say this is the final vertical velocity and this is the final initial velocity. Then if you need to find the final resultant velocity, you can link it with the Pythagoras theorem. And this is a very good trick. Whenever you find one of the velocities, then you can draw the triangle, the vector triangle. It would be very easy for you to find the unknown stuff, and you can represent the angle theta over here. If you need to find the angle, you can easily draw the triangle and find the unknown stuff from here. Okay, so if you had to find the vertical component of the velocity, I have written the data for the vertical motion. For example, the final velocity in the vertical direction would be 0. Final in the vertical direction. The initial vertical component of the velocity is 0. Final is to be found out, Acceleration, since the ball has to go downwards, so acceleration would be plus 9.81. And the vertical distance was 1.25. I used the third equation of motion. And from there, I found the value of the vertical component of the velocity, which was 4.95. The horizontal component of the velocity was 3.0. Now, if you need to find the resultant velocity, then you can just use the Pythagoras theorem, and it would be 3.0 square plus 4.95 square and then square root of it, and thereby you'll be getting the resultant velocity. So let me just clear it off, and what we have is square root of 3 square, which is 9, plus 4.95 square. So we hit it on the calculator, and the answer that we get for this one is 5.78. Now I can round off the answer to 2 SF. It would be 5.8 meter per second. So this component of velocity is 5.8. This not the component, the resultant velocity is 5.8. Now you need to find the angle to the horizontal of what? Of the resultant velocity. So this is your resultant velocity, and you need to find the angle of this velocity to the horizontal. So this is the horizontal, and likewise you need to find this angle theta. Angle theta is already representing the angle of the resultant velocity with the horizontal. Okay, so this angle theta, you can use any trigonometric ratio, sine, cos, tan. I'll go with tan. Tan theta equals to, because if I use tan theta, I don't have to use the values that I've recently calculated. I can use 4.95 perpendicular over base, which is 3.0, and theta equals to tan inverse of this fraction, 4.95 divided by 3.0. Then you can once again hit it on the calculator, and this would be shift tan inverse, then you write fraction, then you write 4.95 divided by 3.0, and you press equals to, and the answer that we get for this one is 58.78, aka into SF you can write 59. If you're not sure about the significant figures, the rule of thumb is leave your answer to 3 SF. That is the safest option that you can have. Leave your answer to 3 SF. Now we need to find the kinetic energy just as it hits the floor. So the kinetic energy equals to 1 over 2 mv square. So 1 over 2, 0.5 as it is. 0.5 is 1 over 2. And the mass is given as, you see there in the first line, the ball of mass 0.5 kg, 0.45 kg. So 0.45 times the magnitude of the velocity, the initial one, 5.8 square. You can carry forward the same answer if you want. So 0.5 times the mass is 0.45 times 5.8, but then square of it, and we hit it on the calculator, and the answer that we get for this one is, in 2SF we can write it, let me press the equals to button, we can write this one as 7.569. So you can write it as 7.6. Okay, 7.569 into SF can be written as 7.6. So let's check out the next one. You need to find the loss in gravitational potential energy. So the loss in gravitational potential energy equals to mg delta H. So mass is once again 0.45, g is 9.81, and the height is, let's see what the vertical distance is, 1.25. So that equals to 1.25. So what we write here is, start with 0, so 0.45 times 9.81 times 1.25, enter. So what we get for this one is to convert the fraction, .5. So let's move on to the next part. So in the next part, they ask, explain why the kinetic energy of the ball in B3 does not equal to the loss in gravitational potential energy. So the kinetic energy is not equal to the loss of the gravitational potential energy. So the kinetic energy as the ball touches the ground, just before the ball touches the ground, in principle should equal to the loss in gravitational potential energy. Or in other words, loss in GPE should equal the gain in kinetic energy. So many of the students would be tempted to write the answer that some of the energy is lost in form of friction, in form of heat, in form of air resistance. The thing is that answer would be wrong because of two reasons. First of all, if the energy is being lost in form to the surrounding in form of air resistance, in form of friction, then the kinetic energy should be less than, the gain in kinetic energy should be less than the loss in potential energy. But here, the kinetic energy, the gain in kinetic energy is even more than the loss in potential energy. So one reason that statement would be incorrect. The second reason is, if you read this thing, it is given in the question that air resistance is negligible. See, over there I have put it in the inverted commas, air resistance is negligible. So if the air resistance is negligible, you're not going to answer any losses for the air resistance, no friction losses, no heat loss. So the reason is, initially the ball was not just having the potential energy, rather the ball was having some kinetic energy as well. So initially, if I write down the equation, the ball was having some initial kinetic energy, and then there was a loss in the gravitational potential energy, GPE loss, equals to the kinetic energy final. Now, if there were no air resistance and the ball was not having the initial kinetic energy, then these two would have been equal. But the problem here is, in this case, the ball is having some initial kinetic energy as well. Alright everyone, so let's move on to the next question. So here we have the next one. Once again, air resistance is negligible and everything is given on the diagram. By considering the vertical motion of the ball, calculate the time it takes to reach the wall. So basically they have simplified the question themselves. They're asking you to break it down or to consider the vertical motion of the ball. So let us write down the data that we have for this case. And the thing is, for this one, the initial vertical velocity for the vertical motion, we'll need to find the initial vertical velocity, and as it reaches the wall, because we are provided with this thing, the ball becomes horizontal. So horizontal means it does not go further upward. So the vertical component of the velocity becomes 0. So Vy, you can say Vy becomes 0, and the initial vertical component of the velocity is to be found out. We need to find it using the method of components, which would be initial component of the velocity in the vertical direction would be 15 times not cos theta, rather sine theta. So 15 times sine 60 be 15 times, so we can hit it on the calculator. 15 times sine 60. And once you find the initial vertical component, you can easily convert, find the unknown value. So for example, we get 12.99, okay? And the final vertical velocity, V, would be 0. Okay, so since I've written the caption vertical motion, so I'm removing the subscripts, okay, just for the sake of convenience. We need to find the time taken. Another thing that we know for the vertical motion is the acceleration, which in this case would be negative 9.81 because we're moving upwards. So if I use the very definition of acceleration, a equals to v minus u over t, and from there I replace these two with each other, a and t with each other. So mathematically t equals to v minus u over a, and v is 0, minus u is 12.99 divided by minus 9.81. Then you once again, negative and negative would be cancelled out. You hit it on the calculator. We write down, insert the fraction first, 12.99 divided by 9.81. Then we press equals to, and obviously negative cancelled out. We would be getting the answer as a positive number, and matter of fact, the answer for the time has to be positive. So what we get in fraction is 1.3. So in 2SF, we get the final answer for time as 1.3 seconds. Okay, then we have the next part, explain why the horizontal component of the velocity of the ball remains constant as it moves to the wall, because there is no force or net force in horizontal direction. Alright everyone, so since you need to find the horizontal velocity, and it would be same everywhere, so you can find the initial horizontal velocity, and that equals to u times cos theta. So do we have the value for velocity? 15 times cos 60. So 15 times cos 60 would equal to 7.5, and then you can write the horizontal velocity would be same everywhere. So since the horizontal velocity is same everywhere, so the velocity as the ball strikes the wall, the horizontal velocity as the ball strikes the wall would be 7.5 there as well. So because horizontal velocity is same throughout the projectile motion. Alright, so this is how we answer this one. Let's take a look at the next question. So here we have the next one. Once again, everything is given on the diagram, and it starts with assume air resistance is negligible. Show that the time taken for the ball to reach the ground after being fired is 3.4 seconds. All right, so we do have the vertical distance, so I'm going to consider the vertical motion, and everything that I'll be writing would be for the vertical motion, so I'm not going to add the subscripts. So distance 57, once again for the vertical motion. Initial velocity is 0. It is the initial velocity, but the vertical component of the initial velocity. I'm considering only the vertical motion. So initial velocity is 0, and acceleration as it goes downward would be 9.81. I need to find the value of t. I can safely use the second equation of motion that is given on the formula sheet. So s equals to ut plus 1/2 at square. This thing would be reduced to 0. S equals to 57. 2 would be multiplied on the other side. A would be divided on this side, equals to t square, and in order to get rid of the square, you'll have to take the square root. So we write everything on the calculator. 57 into 2 divided by 9.81, and that equals to 3.4. In 2SF, this is what we had to show, 3.4 seconds. So see, the same one. Okay, then we have the next one. Calculate the horizontal distance of the ball from the cannon at the point where the ball lands on the ground. Horizontal distance needs to be found, so I'm going to write everything for the horizontal motion, so that's why I'll not be adding the subscripts. Why? Because the caption is there. So for the horizontal motion, we have this thing. Now what is the time? 3.4 seconds. What is the horizontal speed? 41.0. okay, it's given over here. It is essentially the horizontal component of the velocity, because in this case, whatever the resultant velocity is, that is entirely your horizontal component, because we project the object horizontally in this case. So it was 41.0, or was it 41? Yeah, 41.0 times 3.14. So 41 times 3.14. We hit it on the calculator, and the answer that we get to this one is 129. It could be 129 into SF. So 129, or if you want to write, yeah, in 2SF you can even write it as 130. In 3SF would be 139. In 2SF you can write it as 130. So let's check out the next one. Determine the magnitude of the displacement of the ball from the cannon at a point where the ball lands on the ground. Okay, so for the displacement, we need to find the shortest distance. So the shortest distance would be from here all the way over here, and we have to find it using Pythagoras theorem. So the displacement would be horizontal square of the horizontal distance, square of the vertical distance, and then the square root of it. So we do have the value of vertical, and I think we do have the value of horizontal, which we just calculated, 129. Square of it, 57, square of it, and then we put it in the square root, and then we hit it on the calculator. So 129 square plus 57 square, and then we press the equals to button. 141 meters. So 141 meters is the answer for this one. All right, so let's move on to the next question that we have, and an archer releases an okay, so here we have the diagram. Assume the air resistance is negligible. The projectile hits the target over here, and we need to show, in the first part, we need to show that the time taken for the arrow to reach the target is 1.08. So if I draw the simplified diagram, it would be something like this. So your archer, the arrow moves with the speed of 65 meter per second, and the angle with the horizontal is, let's say, not let's say, but it's given 4.30 degrees. Yes, it's given 4.30 degrees with the horizontal, and the horizontal distance between the point of release to the center of the target is 70 meters. Okay, so it's given on the diagram. So what I can do quickly is, I don't know if I'll be using it or not, but what I can do quickly is I can find the initial horizontal component and the initial vertical component. So initial horizontal component would be 65 times cos 4.30, and initial vertical would be 65 times sine 4.30. So in the first part, they ask you to find the time taken for the arrow to reach the target is 1.08. Alright, so you can use the horizontal motion, let's say, and this question is for 2 marks, horizontal motion. So for horizontal motion, I'm going to write the entire data. So horizontal motion, S equals to V into T. The distance in the horizontal direction is 70, and speed is, which we had to calculate, the initial horizontal component, 65 times 4.30. You can hit it on the calculator. 65 times cos 4.30, and this one that we get is 64.82, okay, meter per second. So we can use the same one over here, 64.82 into T, and then time equals to 70 divided by the answer. So 70 divided by whatever the answer was, and from here you get 1.0799, and in that would be rounded off to 1.08. Previous answer. Alright, so for this one we are trying to see how far up in the air does the projectile go, so that we can subtract that distance from the total distance of 1.66. So for the vertical motion, if I write down the data for the vertical motion, so the initial vertical velocity, I'm going to write it as u. I'm not going to add the subscripts because I've written the caption over here. The initial vertical velocity was, let me see from the data, 65 into sine 4.30. 65 into sine 4.30. Yes, then we hit it on the calculator, and you'll be getting the initial vertical component of the velocity, which is 4.87. 4.87. So 4.87 meter per second. Alright, and then what is the final vertical component of the velocity? Well, we can find it out by using the formula V equals to U plus AT. For the vertical, once again, each and everything that I've written over here is for the vertical motion. Okay, for the vertical motion. So V equals to U plus acceleration as it goes up, would be 9.81. And how long does it take to reach the target? 1.08. So I'm going to hit it on the calculator once again. So 4.87 would be subtracted minus 9.81 into 1.08. So the final vertical velocity is 5.72, negative 5.72. What does that negative sign show over here? It shows that the direction of the velocity is reversed. So it would no longer be going upward. Matter of fact, now the component, the target, it would be approaching the target, hence the projectile would be going downward. So we need to find the height above the ground, and I can safely use the third equation from the formula sheet. V square equals to u square plus 2as. Now what is v square? First of all I can rearrange it for the value of s. It'll be v square minus u square divided by 2a. So s equals to v square, which is square of minus 5.72. The negative sign in the square won't make any difference. Minus 4.87 square of it divided by 2 into acceleration negative 9.81. Then we hit it on the calculator. So fraction square of minus 5.72 square of it minus 4.87 square divided by 2 into minus 9.81, and the brackets close. Then we press equals to button, and what we get for this one is negative 0.4587. So I can write it as negative 0.45. How much was that? 459. Okay. Now what does the negative sign show over here? Now since you were considering the upward direction, and if the distance were positive, then if you were going with the convention, which is the upward direction, you were considering positive, but this time the displacement is negative. So what does that mean? It means you have covered a distance below the original point, below the starting point. You're standing below the starting point. So what I'm saying is, if this is the initial axis, let me clear everything from here. All right, so that distance is telling you something. So if this is the starting point, okay, for example, this one. All right, now how far does this projectile go upward? Is if it had covered a distance of plus 0.4, the same one but with the positive sign, 0.459, let's say, then that would have implied that the projectile is above this line, that much of distance above this line. But the negative sign tells you that the projectile is downwards on the lower side of the reference point. The sign of the displacement tells you the position of the object with respect to the reference point. So negative means it is below this point, 0.59. Alright, so what you can do is, there are two different ways. Either you subtract 1.66 and you subtract 0.459 from it, okay, irrespective of their sign. Or the other thing is, you add 1.66 plus you add negative of 0.459, which is exactly the same thing. Basically we are adding these two displacement, but one of the displacement was negative, so it would automatically be subtracted. So if I hit it on the calculator once again, so 1.66 minus 0.459, and what we get is 1.2. In 2SF we can safely write 1.2 meters. So height above the ground would be 1.2 meters. Now once again, if the displacement were positive like this, let's say the displacement was 0.459 but with a positive sign, then 1.66 plus 0.459, and those two would have been added. But here we are adding them, but since one of them is negative, so they'll be subtracted.